Hello, my name is Emil. You're watching my work, and today we're going to look at a simple ECS implementation in C#. Just a little experiment. So let's look at the components we're creating. We're creating two of them, a spaceship in this case, with a physical component. The ship weighs 10,000 tons, and it has 4,000 tons of fuel. Its thrusters can do 20,000 tons. That's a mass to weight ratio of about 2. The flight computer has one instruction to use the main propulsion system to burn for 5 ticks in the x-axis. And it can sense things within 25 meters. And then we have a second ship with similar characteristics, but it's just kind of standing still. It will move, technically, because gravity, the laws of gravity is implemented. So the two ships will have a gravitational attraction, but it will be very little. So if we run this, anytime now, there we go. We will see. I'm printing out the velocity of both entities, and here you can see the velocity going up and then stabilizing because it's no longer moving. And we should see some very small changes, like that, see, over time as the gravity of the two ships attract one another. So that's kind of what's going on there. And as for how the gravity works, we don't want to apply gravity to ourselves. We go through every single other entity in the system, and that's what this query tag is. Then we take the target vector. To calculate the target vector, we subtract the position between the two targets, then we normalize it. We take the length, and then we apply this algorithm, and then we do the F force equals mass times acceleration thing from Newton stuff, like that, and then we apply it. And we apply that to the acceleration. Then the movement system, I think, it will kind of just apply the acceleration as need be to the velocity, and the velocity will get applied to the position. The propulsion system will use fuel up, and then over here it will kind of subtract the calculate the thrust vector and apply it to the acceleration. And then finally the flight computer will go through the instructions one by one and execute them all until that is done. It's a real simple system. We can quickly look at this. Is the sensor suite, the physical component, which is acceleration, velocity, position, mass, the fuel tank, the flight computer, which has the flight instruction as well as the state, cold jets, and then finally the chemical engine. The query attribute and the system attribute are just markers. That's how things are marked. So we have the system method. This is a system. This is a method in the system. And the query means we're querying all the other entities in range. So that was what that means. A more simpler version doesn't have that. So the way the system works is whenever a entity has all the components that are arguments, it will automatically just feed them in. So this whole thing binds itself using reflections automatically. There's no hooking, right? So it says, okay, does a component have a physical component, and does it have a list of targets? And for the same goes for the movement system. Okay, we want a physical component, or in the flight computer, do we have a flight computer and a chemical engine? If so, do this logic. And for those of you who want to know how it works, the component just has a Go ID. The ECS engine is semi-complicated. There's also just some helper stuff. So here we go. When we load, we get all the types of base type component. We go through them. We look for the system attribute. We go through all the methods. We find the valid ones and register them. That's what you see up here. When we register, we check all the parameters and query them and check for query tags and so on. Then when we try to actually do the step, well, first we hold a cache. So of the IDs, which are indices into the component array. So that would be this one. So yeah. And then once we have the indices, when we step, we just go through everything, find matching things, cast it to arrays, make the lists, and invoke the appropriate method. It's relatively fast. It's not the fastest thing in the world. It is reflections, but with the caching, it's okay. It's just a more experimental way of trying out different interfaces. So, for example, a interesting approach would be to have the query take an argument of range. So it will only give you items within range, and then store everything in like a subdivided grid or like a tree structure or like an octomap or something, so that you don't have to go through every single entity, because it might start bogging down, you know. So yeah, the only things that are in the range of the suite will actually get sent here. So that would be a much smarter system. Yeah, I mean, it's kind of a neat little thing. Also, multi-threading would be something to experiment with, obviously. I don't know. I find it interesting. As for the vec3, it's just the normal stuff, you know, like cross dot and normalization, basic vector mathematics. I like it. I really do like it. I might continue experimenting on this, or try and slap a 2D UI on it, or focus on making a bit more advanced simulations. But all in all, it's a very interesting experiment. I hope you found it as interesting as I did, and I'll see you next time. Bye bye.